I really like this question because it's hard, but in a way, it is still solvable using what I think is the easiest, most helpful strategy on the SAT. The plug points into equations strategy. And if you've seen some of my other videos, you've seen me use this strategy many, many, many times. Now, in this case, it can be a little hard because it's not very obvious that we have a point to plug in. It's really obvious that we have an equation. I mean, it's the first line there. The point, though, is kind of twisted up on us. But we have to remember that function notation is really a way of representing a coordinate in a slightly different way. So I'm looking at this piece right here, okay? So you may have heard that like f of x is equal to y, and so this 0 here is kind of functioning as the y coordinate. And then the x coordinate, which is, there's no x here, but it's the x coordinate, is kind of an equation in a way, h minus 3. It's its own little mini thing. But it's a point. We have an x value and a y value. And I know in the f of r, it doesn't have an x either, but we have to be comfortable with them switching out the letters and just, you know, it's more about the placement of the letter rather than the specific letter itself. So that r is behaving like an x. It's in this position that's normally taken up by the x coordinate. And so anything that's in that parentheses can be substituted for the x coordinate in the equation. So in this case, if there was any number in place of r, we could substitute it in and we could solve this thing for f of r, f of 3, whatever it is. In this case, it's h minus 3, which isn't a number, but it still behaves the same way. We can plug the point into the equation, substituting at h minus 3 in for the x or r position, and then 0 in for the y. So it should look like this, okay? F of r or f of h minus 3 is going to be 0. And then it's going to get a little messy. I'll use parentheses to kind of show it, an extra set of parentheses. H minus 3 is going in place of r, so it's h minus 3 minus 4 times h minus 3 plus 1. And notice I'm not really doing any math as I substitute. I'm just kind of putting things in their places so that I'm not doing two things at once, okay? Once I do that, my instincts for algebra kind of take over. And I'm just like, all right, well, simplify stuff, right? If I have any equation, I should start to simplify it so that I can start to solve it. So in this case, these parentheses that I used to kind of plug in this h minus 3 in a neat, organized way, they're mathematically irrelevant. There's nothing before them that's going to get distributed, so these parentheses can kind of just be dropped. And when I do that, I can start to combine some like terms. So this minus 3 and this minus 4 are going to be combinable. Same with this minus 3 and this plus 1. So once I do all that, I'm going to have something that looks a lot more familiar. H minus 7 times h minus 2 squared. All right, now this is starting to look better. Here's a case, though, where if you start to be a little too robotic about your algebra, you're going to just take this too far and start to dig yourself into a pretty deep hole and make a big mess for no reason. Some people want to foil here, and they want to start, multiplying the h minus 2 out and get h squared minus 4h or whatever. We don't need to do any of that because this equation is already in a really great place because it's equal to 0. Remember, anytime we have something complicated with these parentheses terms, anything with an exponent, we really want to make it equal to 0 so that we can factor, which is what we've already kind of got here, is it looks like it's already been factored for us. And the reason we factor is basically because we can then turn the little factors into mini equations and solve for x, or in this case, h. So this should look very similar to how you deal with like normal quadratic equations, right? So the h minus 7 in particular is really simple. What value of h would make that true? Well, just you can see it, or you can add the 7 to both sides and get h equals 7. And that is one of the answers for this question. If we did the same thing on the other side, this 2 seems to complicate things, this squared, but it doesn't really because, well, if we took the square root, well, the square root of 0 is 0, so h minus 2 would still be 0, and so h would still be positive 2. And that's the other answer to this question. Yeah, it's a little weird. I definitely get why people would be confused by it. But one of the things I really like about the SAT in general is how they take stuff that's not weird, make it a little weird, and then kind of try to leave you up to solving it. And so if we just get comfortable with untwisting the stuff that the SAT has twisted up, we can do a lot better on the math sections, the writing, the reading. It's kind of throughout the entire test. Is they take stuff that you're used to, they twist it up, make it look a little different, and try to intimidate you into quitting. But if we recognize here that we have a point and we have an equation, we know that this great strategy exists. Plug points into equations. You don't need to ask deeper questions. Do it, see what happens, and odds are pretty good that the answer will appear in some way. And hopefully, even if you were confused at the beginning, as you plug in and you start to work through what you've got, you recognize what you were actually supposed to do all along. And it is really just a factoring kind of question. It's just disguised. So hopefully that helped. When in doubt, if you have points, and you have equations, plug points into equations.